A baseband signal must be encoded before transmission on the medium. We will be going through a few basic encoding methods. The first encoding method is called unipolar encoding. In unipolar encoding, a 1 will be encoded with a positive voltage and a 0 will be encoded as 0 volt. The logic 1 or 0 is referred as bit, and the positive voltage or 0 volt is referred as signal. Due to the presence of stray capacitance, unipolar encoding is not suitable for long-distance transmission. Another limitation of unipolar encoding is that the synchronization problem when there is a long series of logic 1 or 0 in a row. To understand this, with the given waveform, if the logic levels are not shown, are you able to know how many 1 and 0? Next, we look at polar encoding. Polar encoding is also called non-return to 0 encoding. Logic 0 is represented with a positive voltage, and logic 1 is represented with a negative voltage. The signal's symmetrical, around 0 volt. Polar encoding is used in RS-232 interface, a legacy interface used in PC. The polar encoding eliminates most of the residual DC problem. It helps to reduce the power required for transmission by half. However, polar encoding has the same synchronization problem as unipolar encoding. Now we come to bipolar encoding. Bipolar encoding is also known as alternate mark inversion. It has 3 voltage levels. Logic 0 is represented with 0 volt. Logic 1 is represented by alternating polarity pulses. That means the polarity of a logic 1 is the opposite of the previous logic 1. In another word, if the first logic 1 is positive voltage, the next logic 1 will be a negative voltage. Bipolar encoding eliminates the residual DC problem. It has improved the synchronization problem, except for transmission of long string of zeros. The last encoding method covered is the Manchester line encoding. In Manchester line encoding, a logic 0 is represented by a high to low transition, and a logic 1 is represented by a low to high transition. The mid-bit transition also serves as a clocking mechanism. In Manchester line encoding, the average voltage is 0 volt, so there is no DC component. The transition serves as a clock, so it doesn't have the synchronization problem. The frequencies of the signal doesn't vary much, so it requires the least amount of bandwidth. Compare with the other encoding methods mentioned in this video. Next, we talk about transmission rate. Bit rate is referring to the number of bits transmitted in 1 second. Baud rate is referring to the signal unit transmitted in 1 second. If the signal voltage has only 2 values, the baud rate is equal to the bit rate. If each signal voltage represents 3 bits, as shown in the table, the bit rate will be 3 times of the baud rate. The baud rate also determines the bandwidth required to send the signal. In another way, the signal states or voltage levels depends on the number of bit it represents. If there are 2 voltage levels, it can only represent 1 bit or 0 and 1. If there are 4 voltage levels, it can represent 2 bits. In short, the level required is equal to 2 to power of n, where n is the number of bits it represents. Bit rate can also be calculated by multiplying the baud rate with the number of bit per signal. The baud rate can be calculated by dividing the bit rate with the number of bit per signal. In this example, each signal carries 4 bits, and 1,000 signals are sent in 1 second. Therefore, the baud rate is equal to 1,000 baud per second. The bit rate is equal to baud rate multiply by number of bit represented by one signal, which is 4. Therefore, the bit rate is equal to 1,000 multiply by 4 or 4,000 bit per second. In this example, the bit rate is 3,000 bit per second, and each signal represents 6 bits. Therefore, the baud rate is equal to 3000 divided by 6, or 500 baud per second. In this last example, the baud rate for both waveforms are the same. However, the bit rate for the waveform on the right is double of the one on the left. This is because each signal in the waveform represents 2 bits. In the keyboard, each key is represented with a binary code. There are 2 different coding standards, ASCII code and Unicode. ASCII code is limited to only 128 characters, and Unicode can represent more than 100,000 characters. This is a table of the ASCII code. Thank you for watching.